The last thing we're going to take a look at in Chapter 6 is using the normal distribution to approximate a binomial situation. So sometimes it would be really hard to solve a binomial problem without this help. So we're going to take a look at an example of that. It says, for instance, if we know that 10% of men are bald, what is the probability that fewer than 100 out of bald men out of a sample of 818 are bald out of a sample of 818? To solve this problem using a binomial distribution, we'd have to figure out, let's take a look. So traditionally, or back in Chapter 5, when we did the binomial distribution, well, we said there were 10% of bald men, and we had 818. And then we thought about it, and then fewer than 100, that would be 99, right? And then I'd write down what I got. And then we'd have to do 98, and then we write down what we get. And then we do 97. And then we write down what we get. And then we do 96, and then we write down what we get. I'd have to go all the way from 99, 98, 97, 96, right? All those answers all the way down to 1, and then add those up. And you can understand why that's not really a feasible option right now, because that would just take way too long. So what you tend to see is when your normal distribution is big enough, or when it meets certain criteria, the normal distribution, if we were to plot it, it starts to build a distribution that looks like this, right? And you see, even though this is a discrete probability distribution, what does this look like? It's still symmetric, it's still bell-shaped, it still resembles a normal distribution. So we can use the normal distribution to approximate a binomial. And that's what we're going to do here. Now there's a couple things that need to be true for us to be able to do this. N times P, remember N is the number of trials and P is the probability of success. When we multiply those together, it must be greater than 5. And the other case is N times Q must also be greater than 5. So we need to check to make sure those criteria are met before we can do the normal distribution to approximate the scenario of a binomial. The next one, which we'll talk about in a second and we'll get in a lot more detail with, it's kind of strange, but we're going to use what's called a continuity correction here, and we're going to want to make sure, since this is a discrete probability situation, we're going to go right below or right above the number and we are looking for, and we're going to have something like 100.5 or 99.5 in terms of what we put in the normal distribution. We're getting a little ahead of ourselves, so let's look at this specific problem we're looking at. It says we got 818 men, right? And N here, let's figure out what N, P, and Q are. N would be 100. P is the probability of selecting a male who is bald, which is 0.10. And then Q, remember Q is equal to 1 minus P. So Q would be 0.90. Now we need to make sure that our conditions of NP and NQ, when we multiply them, are greater than 5. So N times P would be 818 times 0.1, which is 81.8. And then N times Q would be 818 times 0.90. I don't know that one, so 818 times 0.9 gives us 736.2. Okay, so we're checking to make sure, are both of those bigger than 5? I take a look at the first one and we say, yep. And we take a look at this one and we say, yes. So are these both bigger than 5? Yes. What that means is we can keep going with this problem. And the next steps here are going to be able to find the mean and standard deviation. So the mean, here's good news. You did the mean right here, didn't you? So we did N times P and we found the mean was 81.8. Now we need to go find the standard deviation. Remember, back in Chapter 5, it's n square root of N times P times Q, which in this case would be the square root of 818 times 0.1 times 0.9. So let's figure out what that is. It is 8, let's do square root of 818 times 0.1 times 0.9. And we get 8.58. Now, that's very helpful because I'm now going to go and we're going to take a look. We're going to work with this normal distribution. We're going to want to work with this one right here because we're trying to find the probability of fewer than 100, right? And this is where this gets a little tricky because we want fewer than 100, right? So I've got 100. We want fewer than. That means, think about it. Do I want to include 100 or not? I do not want to include 100. So we're going to stay right below it. And the number we're going to put into the Excel spreadsheet is actually 99.5. So since we want fewer than 100, we're going to go just below. That's what I was talking about up here with this continuity correction. So we're going to use 99.5. So the probability that we select fewer than 100 men is equal to, let's figure this out. We're going to put this in the Excel spreadsheet. My mean was 81.8. My standard deviation was 8.58. And I'm doing fewer than 100, so we do 99.5. And so we're picking this one right here. So the probability that fewer than 100 men are bald is 98%. Okay, so in the next video, we're going to look at some more applications of this.